What now, right? So now, having this enormous amount of information about what hosts are there and what are the services they are running, we will have to get an idea about what's the nature of those hosts and what are these different services, right? So something we can guess from what's the number of the service. So to some extent, we can expect anything running on port 22 to be an SSH daemon, you know. But sometimes SSH daemons migrate to some higher port numbers just because they are scanned less and brute forced by network worms rarely. Okay, so we will have to see what comes back to our request to these services. First of all, let's focus on the hosts themselves. So they run different flavors of operating systems, and we will be able to assume to some extent, with some probability, yeah, that these are certain operating systems. For example, based on the implementation of TCP/IP stack, we will have an idea whether that's a Windows host or a Linux host or a NetBSD host or whatever, right? So every operating system is developed by a bunch of guys who, yeah, they are trying to be in line with the standards, the RFCs that are there, yeah. So they follow them, but at some point they become they make some individual very specific design decisions or implementation steps that designate one implementation of the stack from another. And TCP/IP stack is something that is pertaining to the operating system. So every service, right, every application that runs this service on the box, yeah, they do not implement TCP/IP stacks themselves. They always rely on what's going on and what's provided by the operating system. So what are these possible qualities that designate that can allow us tell one implementation from another? So, for example, TTL numbers that supplement TCP/IP packets, right? They are different. They're sometimes chosen differently, and TCP window sizes, default TCP window sizes, and the dynamics of their changes based on the network parameters, the network latency, or the success rate of transmission, and so on. So these are different features that just historically or by some objective reason have been chosen like that and behave like that. This is not life, right? So this is not very different in nature, but still there is this slight deviation that gives us an idea that yeah, this is Linux, you know. So you won't be able to see the specific distribution out of this behavior, okay? But you will predict that this is Linux kernel version number 4.2 or 2.6 and so on, okay? And for that, there will be some need for the target to be configured somehow. So, for example, if there is no open port, there is no chance we will get in touch via TCP/IP fully, you know, to the extent required to make some assumptions or conclusions, right? It's even better if there is an open port and a closed port, because it will behave dropping the connection attempts, it will behave in a certain manner and it will allow us to get more information out of it. What's the difference between the services? So different services running on the same ports, they will definitely use some specific banners, for example. Yeah, so if there is a banner, it won't be the same. Okay, so an SSH running on different systems will still be SSH, but maybe it will be supporting different SSH protocol numbers. Yeah, or sometimes, normally, even SSH just discloses its software version, yeah, because yeah, SSH security is critical, and every time you advertise that to the internet, you have to be sure that everyone is trusting you with your pace of updates to the main repository, right? So every fix is applied and everything is okay. They can connect to you, and your host cannot be abused by someone else to compromise them, okay? There are slight protocol nuances. Some of them we have already discussed, for example, in SMTP, right? So some services expect you to behave differently, and this will give us an idea. Our tools will make conclusions about what these services are based on slight differences in processing the protocols that should be common between different services, but still there are differences. So how can they do that? Yeah, so this line basically is the reason why I shame on me. Yeah, I do not remember the maximum number of connections that can be established, TCP connections that can be established in the system, right? So of course I made this mistake. The correct number is 6500, 65,539, right? Of course 535, because there is this very cool option that not many are aware of in Nmap. Every time you specify a port or a list of ports to Nmap, you use this -p, right? So -p and then the numbers divided by comma, right? Or the ranges of IP addresses. And when we scan all the possible TCP numbers, we normally do this. We do designate them by 1-65,535, correct? Yeah, but you can skip that. You can just put dash there, and it will designate all the possible TCP numbers, and Nmap will go through all of them. What it will do to fingerprint them, it will perform this comparison to the database it has locally, yeah, if you specify this dash as capital V. So it will go through the versions of all services that you have and make some assumptions about them. At least it will verify that they support the protocols that relate to the service port numbers, yeah. So if it's HTTP, it will confirm, yeah, that's HTTP. It will maybe make assumptions based on the banner data and the comparison to the database they have locally. And dash capital O will perform this operating system fingerprinting, and this requires a lot more data because there are many different TCP/IP implementations of the stack, right? Because it is updated all the time. Different kernel versions have different behavior, right? So the fingerprints are stored in these very long and readable strings in the database, and even so, they do not guarantee you the correct identification of a certain operating system version. Okay, so unfortunately, you will have some level of precision. Yeah, so it will tell you that this is Windows. I'm 95% sure. Yeah, so literally it will give you these numbers, and it will give you a lot of them. So 98% probability it's Windows 7, 92% probability it's Windows Server 2003 release 2, and so on. Yeah, so you will know it's Windows, but will it be enough? You know, so as you might know, when you're exploiting a remote memory corruption in a Windows service, you will be dependent even on the localization of a specific version of Windows. So the situation is that offsets in the memory are different for different localizations. So if you have literally this one shot of exploiting a vulnerability, you will have to be really careful and be really sure that this is the version of Windows that is exploitable by the code you have constructed or found. Okay. Yeah, so you can play around with this command already with your home router or any other equipment your own, but we will have it used in our demonstration later. And then, on the other hand of this universal approach by using Nmap, you will have a lot of protocol-centric and architecture-specific even tools. For example, SNMP walk, if you find some UDP ports or 161, yeah, you will have chances to disclose a really interesting and sensitive information about what's going on in this NTP world. So SNMP, sorry, it's a protocol that allows you configure and query hosts for information. Okay, so it's mainly used in the networking world. So network equipment normally communicates to one another using SNMP, and it's almost in most cases somehow misconfigured. And sometimes it's left open to public, not public, but to the guys who have access to the network. Okay, because it's used only by the networking guys, and they sometimes assume that no one else can access it. Of course, pen testers can and have to access it, and this will give you information, for example, about what processes are running in the system, right? So and what listening ports they have open. Okay, so somehow going further and having already access to the host configuration, you will, for the sake of this exercise of service identification and fingerprinting, have very valuable data. Okay. NBG scan, of course, will be useful when you are dealing with Windows, because it basically gives you an idea about what is running and what RPC services are there and what numbers they employ, just to give you a complete understanding of what are all those higher ports are, all these 5-digit figures that accompany RPC services normally. And the num for Linux, as it says, it runs mainly on Linux, and it is just a script that employs a lot of SNMP related and SMB related and other tools that basically produce large but interesting text reports about what's going on, and they are as long as more misconfigured the hosts you scan are. Okay, so if it's an Active Directory domain controller, for example, yeah, you have chances to get the list of all groups in there and all users in there, and information about what's the password policy of this domain and so on. So this is really cool overall, but in terms of identifying running services and operating system versions, it is very important, because yeah, if someone somewhere allows null share connection, yeah, so it most probably will give you complete information about what's the version of the operating system that is run on that host. Okay, if it's Windows. Okay, so yeah, let's wrap it up by network mapping tools and techniques, and then some final thoughts and some advice I have to share with you to save you a lot of time out there.